If you're in a clinical microbiology lab, you know the CLSI M100. It's basically the rulebook for antimicrobial susceptibility testing. It is absolutely essential. But let's be honest, it can also be pretty dense and a little intimidating. So, in this explainer, we're going to decode its core principles so you can navigate it with a lot more confidence.
So picture this. You've just identified the pathogen that's causing an infection. Great. But now comes the really critical part. What antibiotics do you test? And which of those results do you actually report? This decision, it's not just a technical one. It's a huge patient safety issue. And the CLSI M100, well, that's your roadmap for making the right call.
So we're going to walk through the M100's core logic together. We'll start at the very beginning, selecting the right agents. Then we'll move on to how you interpret breakpoints. After that, we'll talk about the built-in safety net of intrinsic resistance. And we'll finish up with some crucial reporting warnings that you can't ignore.
Our journey really begins with tables 1A through 1J. This is ground zero. It's the foundation for everything else that follows. Before you can even get a result, you have to decide what to test in the first place. And these tables are what guide you on which antimicrobial agents to even consider for your panel.
But the M100's guidance is so much more than just a list of drugs. It actually pushes you to think critically. You have to consider what's approved for clinical use, the specific patient, and the specific organism you're dealing with, and of course, your own hospital's formulary. It also encourages smart strategies like cascade reporting. That's a method where you report the narrow-spectrum drugs first and only reveal the bigger guns, the broader spectrum options, if the first ones don't work. That's a key principle of good antimicrobial stewardship. Okay, so you've used Table 1, you've selected your agents, you've run the test, and now you're left with a raw number. It's either an MIC, a minimum inhibitory concentration, or a zone diameter from a DIS test. But what does that number actually mean? That's where tables 2A through 2J come into play. They're all about interpretation.
See, this is the logical next step. Table 1 helps you choose, and Table 2 helps you interpret. These two sections work hand in hand. You really can't have one without the other. This is the part where you translate that raw data into a clinical category we can all understand: susceptible, intermediate, or resistant. These tables right here, they are the heart of the document. They give you the specific zone diameter and MIC breakpoints that turn your raw lab data into something clinically meaningful. This is where the numbers become actionable information for the doctor.
But listen, these tables are so much more than just lists of numbers. They are packed with vital context. I'm talking recommended testing conditions, quality control or QC, parameters to make sure your tests are even accurate. They also have these crucial comments on specific organisms and guidance on some of the newer categories like susceptible dose dependent. So here's the key takeaway. Always read the footnotes, not just the numbers in the chart. Now for one of the most powerful tools in the M100, Appendix B. Honestly, I think of this as the document's built-in safety check. It's a tool that's specifically designed to help you catch unusual results and prevent some really serious reporting errors. So, what exactly is intrinsic resistance? Well, the document defines it as an inherent, innate resistance. In simpler terms, it's a resistance that a bacterium is just born with. It's not something it picked up along the way, it's a fundamental characteristic of that species. A classic example is that Klebsiella species are just naturally resistant to ampicillin. It's just who they are. And this is what Appendix B looks like. It's a really straightforward table. On the left, you've got the organism, and then across the top, the antimicrobial agents. If you see an R in a box, that means that organism is intrinsically resistant to that drug. It is an incredibly powerful reference tool to have right there at the bench.
So how do you use this table in your day-to-day work? Well, it serves three key functions. First, it's a reality check. If your test says an organism is susceptible, but this table has an R for resistant, that's a huge red flag to double-check your work. Second, it can help you confirm your organism's identification. And third, in some cases, you can actually report resistance based on this table alone without even running a test, which is both efficient and super safe.
Okay, let's shift gears to our final section, and it's a big one. Sprinkled throughout the M100 are these explicit warnings, rules that are designed to prevent major clinical errors. And these are not suggestions, they are directives that you absolutely cannot ignore.
Let's start with what is maybe the most critical one. This warning is all about isolates from cerebrospinal fluid, or CSF. The M100 is crystal clear here. For these incredibly serious infections, there are certain drugs you just must not report, even if they look susceptible in the lab.
This is the do not report list for CSF. And the reason is simple. These agents often fail to treat central nervous system infections effectively, a lot of times because they just can't cross the blood-brain barrier. So reporting a susceptible result for any of these could mislead a physician into choosing a therapy that won't work, with potentially devastating consequences. This list is a non-negotiable safety guardrail.
And the warnings don't stop there. Another major one that's highlighted in Appendix B involves two really common enteric pathogens, Salmonella and Shigella. This is another classic case where lab results can be super misleading if you don't have the full clinical context.
This brings us to a really crucial principle. What works in a test tube doesn't always work in a patient. The M100 warns that for Salmonella and Shigella, certain agents, like aminoglycosides, might look active in vitro, but they just are not effective clinically. Therefore, they should never ever be reported as susceptible. This is a perfect example of how the M100 bridges that gap between lab data and real-world patient outcomes.
So, there you have it. We've seen the framework. You select with Table 1, interpret with Table 2, you verify with Appendix B, and you always obey the warnings. The CLSI M100 isn't just a book of numbers, it's really a guide to clinical reasoning. And by mastering these principles, you move beyond just generating a result to actively contributing to better patient outcomes and smarter antimicrobial stewardship.